Hello, Dr. Armstrong here, coming to you from the 15th floor of Compass Cove in Myrtle Beach, South Carolina. Down here to play a little golf. Apologize for the video getting out a little late, but I have moved the deadline for quiz chapter 6 back to Sunday, 10 p.m. Those of you who have taken it, if you want to keep your score, let me know. If you want to watch the video and take it over, let me know, and I can delete that and you can take it again. Chapter 6, the elbow, wrist, and the hand. Basically, we're dealing with three main bones and three main articulations. Now, like in the other chapters, well, in chapter 5 and the ones to come, you need to know the landmarks, obviously, and it's the easiest way to identify the bones. It's also helpful in helping to remember the origin and insertion. Note the movements as well. For example, with the humerus, at the proximal articulation, it's circumduction at the shoulder. And then with the ulna, it's flexion at the distal humerus. But the radius pivots on the ulna. And you'll see how that is significant in regard to the muscles that we look at in terms of flexion of the elbow. Well, let's talk about elbow flexion. And it had the three B's. Those are the muscles that flex the elbow. The bicep is the strongest flexor. It flexes and supinates. It crosses two joints, so it also flexes the shoulder. And remember that when we talk about a muscle that crosses two joints, it means it has two functions. And in this case, since the two heads of the proximal attachment cross the shoulder, then it is responsible for some flexion of the shoulder. The bicep is engaged most forcefully when the forearm is supinated. So, for example, if we're talking about a pull-up versus a chin-up, you probably know that the chin-up, palms facing me, the chin-up is easier than the pull-up. You can usually do more with the chin-up. The reason is because as I supinate the forearm, the bicep comes into play. Now here's a simple example that I like to use in class to illustrate this. What I'd like you to do is to put your arm out like this with your palm down. I want you to put your hand on your bicep, and I want you to flex the elbow with the palm down. Okay, now, do you feel much going on in the bicep? Probably not. Okay, put it down here and with the palm up. Now, I've supinated my bicep, hold on to it, flex, and all of a sudden, the bicep pops up. Okay, so it flexes and supinates, but it's only active, or most active, when you have the forearm supinated. The distal attachment is on the tuberosity of the radius. So when we talk about the radius pivoting around the ulna, that's what happens when you supinate. So in order to get like I said, the full force out of the bicep, you have to supinate. The brachialis, this is what we call a typical or a true flexor of the elbow, because that's all it does. It flexes the elbow. And the reason that it is a true flexor is that its distal attachment goes to the ulna, and while the radius pivots around the ulna basically stays home. It just flexes. It doesn't pivot or adjust at all. It simply flexes, and so the distal attachment is on the ulna. So when the brachialis contracts from both ends to the middle, it pulls on the ulna, allowing the forearm to flex. And then finally, you have the brachioradialis. Now this one is more of a stabilizer because of the positioning of the proximal and distal attachments. This is a case where the distance of the proximal attachment to the joint is shorter than the distance of the distal attachment to the joint, making it a stabilizer. Normally, when we're talking about the brachialis or the bicep, the distance from the proximal attachment to the joint is longer than the distance of the distal attachment to the. And I know this sounds like double talk, but basically that's how you define a spurt and a shunt muscle. The brachioradialis is a shunt muscle. And here's I really like there's an illustration. I don't think it's in the text, but I'm sure it's in one of the PowerPoints. And when we talk about palpating a muscle, it's really easy to identify the brachioradialis when you are flexed against resistance. The muscle that should kind of pop up is this one right here. That's the brachioradialis. Okay. Now, while the brachioradialis is more of a stabilizer, it is counted as a flexor of the elbow. Elbow extension. Let's talk about that. The tricep is obviously the most powerful of the elbow extenders. The three heads of the proximal attachment basically cover the entire surface of the posterior humerus. So when you flex the tricep in extension, you can feel the three heads basically on the backside of the humerus. And the distal attachment is on the olecranon process of the ulna. So when you are looking at the landmarks of these three bones, make sure that you understand what the olecranon process is, because that's an important landmark in terms of the distal attachment of the tricep. It's not a typical extensor or a true extensor because it also crosses two joints. So it performs two functions, extension of the elbow and extension of the humerus. Now you recall that the bicep, it crosses two joints, and it's flexion of the shoulder and the elbow. In the case of the tricep, it's extension of the shoulder and the elbow. Now the anconeus muscle is what we call a typical or a true elbow extensor. It attaches to the distal humerus and the proximal ulna, and all it does is extend the elbow. Okay, let's talk a little about pronation versus supination. Now, there's a kind of a lengthy discussion in the PowerPoint about pronation and supination with a number of illustrations. And first of all, you need to understand that the muscles that supinate generate more power than the muscles that pronate. And the primary reason for that is the bicep. We recognize the bicep as a powerful flexor, but it's also a powerful supinator as well. This would become significant, for example, when you're using a screwdriver. Okay, and it has to do with whether you're screwing in a screw or unscrewing and which hand you're using. So if you are right-handed and you are screwing in a screw and using the screwdriver like this, then note that as I screw the screw in, it's clockwise, and I am supinating. Whereas if I'm using my left hand and I'm doing the same action, I'm pronating. So when I get to a point where I'm really going to have to crank pretty hard, if I'm right-handed, I'm probably going to exert more force than if I'm left and use the left hand, simply because the supinators are more powerful. Now here's something to remember. If I were to let's say that I'm just reaching out straight like this, and I'm screwing in a screw, and I reach a point where it's kind of tough, and what's working on my behalf here? The supinator muscle. Now, if I really want to engage the bicep as a powerful supinator, I'm going to have to kind of lean in on it, and notice that what I'm doing is flexing the bicep, which engages the bicep more as a supinator. Okay, see how that works? And if we are unscrewing a screw, okay, all of a sudden if I'm the left-hander and I'm unscrewing the screw, I have more of an advantage than the right-hander, because now I'm supinating counterclockwise and I'm unscrewing a screw. And again, if I am starting out and it's kind of tight and I have my arm stretched out like this, if I bring my shoulder in and I bend the elbow, flexing the bicep, I have more power with the unscrewing of the screw with the left hand. One of the examples I have, an illustration I think in the PowerPoint, is unscrewing a oil filter in a car. Now, I don't know how many of you have ever tried to do that. Anymore, most people don't change their own oil because it's easier to go to a place and have them do it for you. But if you ever have the opportunity to do it, just to know how to do it, first of all, most of the cars now, there's so much stuff under the hood you can't identify it, but some of the older cars, you might be able to find the oil filter, but you're reaching in, and usually if you use a oil filter wrench to take it off, but you tighten it by hand. Okay, and a lot of times you're reaching in like this, and fortunately you don't have to, they just want you to hand tighten it. But if you reach a point where you really, you know it needs to go a little bit tighter and you're reaching as far as you can, then you may have to engage the wrench because you can't reach in and bend the. Now, that's an example, like I said, that you may never have to worry about, but the idea is for you to understand the concept there. The bones of the hand, note that there's 2 rows of carpals. There's a good illustration on page 102 in the text of that. Now, for this class, you don't have to memorize all the bones of the hand, but at some point, depending upon your career path, you're going to have to. So just make sure that you know them. When you do, make sure that you know them both ways, and also, let's say that you memorize them on the left hand with the palm down, and you are given an exam where it's the right hand palm up, or bent a different way, and it becomes confusing to you. Well, that's why you need to kind of memorize them both ways. Most people use mnemonics to memorize bones of the carpals, the tarsals. It's a little easier that way. I'm sure you've done that in the past, where memorizing particular lists of words. As a matter of fact, my guess is those of you who are in athletic training specifically could ask professors there, and they probably know some mnemonics in regard to memorization of bones of the hand. Some final comments here. This is as far as I'm going in chapter 6 in this video. Obviously there are more muscles that are in the text that you'll need to become familiar with, but I've hit on some of the most important issues of this chapter. Doesn't mean you shouldn't spend time with the rest. There'll be some quiz questions over the entire chapter, which is why, by the way, if you've taken the quiz already and you feel like this might have helped you a little bit more, you can let me know. I can delete that quiz, you can take it over. And remember that the muscles listed in chapter 6 are certainly not exhaustive in terms of, especially in terms of the intrinsic muscles within the hands and the fingers. There are many more. but these are the ones that we cover in this class. And as you've probably noticed as we've gone through 5 and now 6, and you'll see throughout the rest of the chapters of the text, that we are choosing to go over the muscles that are most familiar, ones that you will come into contact with most. So I wish you the best. Next time I talk with you, I'll be back in Ohio. So long.